In question 2 of this exercise, we have to find whether the first polynomial is a factor of the second polynomial in each case by dividing the second polynomial by the first. So for example, in part 1, the first polynomial is this quadratic polynomial t square minus 3. The second polynomial is this fourth degree polynomial 2t4 plus 3t cube minus 2t square minus 9t minus 12. And we have to check whether the second polynomial is perfectly divisible by the first polynomial, whether the first polynomial is a factor of the second polynomial. And that will happen if in the division process of dividing the second polynomial by the first polynomial, we are left with a remainder of 0. So what we're going to do in this question is, in each part, we are going to divide the second polynomial by the first polynomial using long division. And then we're going to check the remainder. If the remainder is 0, then we can say that the first polynomial is a factor of the second polynomial. So let's start with part 1. So in part 1, the divisor polynomial is t square minus 3. So let's write that first, t square minus 3. And then let's write the dividend. So the dividend is 2t to the 4 plus 3t cube minus 2t square minus 9t minus 12. So this is the dividend. Now let's start with the long division process. So the first multiplier we'll need is what we need to convert t square into 2t to the 4. So we will need the multiplier 2t square, and this generates the terms 2t to the 4 minus 6t square. So minus 6t square we will write here. Now let's subtract. So we get 3t cube, and then from the t square terms we get plus 4t square, and then we get minus 9t minus 12. These are simply the terms that we're bringing down from here. Now the next multiplier we will need is what we need to convert t square into 3t cube. So for this we will need the multiplier 3t, and this generates the terms 3t cube minus 9t. So minus 9t we will write here, and now when we subtract we get 4t square minus 12. So this is all that we get. And then finally we need a multiplier to turn t square into 4t square, and that will be plus 4. So we write plus 4 here, and this generates the terms 4t square minus 12. And when we subtract, we are left with nothing. We are left with 0. So what we observe is that the remainder is 0, which means that the dividend is exactly divisible by the divisor, or the divisor is a factor of the dividend. So that completes part 1. Now let's go to part 2. In part 2, the divisor polynomial is x square plus 3x plus 1, a quadratic. So let's write that first, x square plus 3x plus 1, and then we will write the dividend. The dividend is a fourth degree polynomial in this case, 3x to the 4 plus 5x cube minus 7x square plus 2x plus 2. So this is the dividend. Now let's start the long division process. So first we need a multiplier to turn x square into 3x to the 4. So that multiplier is 3x square, and this generates the terms 3x to the 4 plus 9x cube. So I write this here, 9x cube, and then 3x square. So we write this below, minus 7x square. Now we subtract this from the dividend, and what we get is minus 4x cube minus 10x square, and then we bring down the linear and constant terms 2x and plus 2. Now the next multiplier we need is to turn x square into minus 4x cube, and this will be the multiplier minus 4x. Now this generates the terms minus 4x cube minus 12x square and minus 4x. So let's subtract again, and this time we will get 2x square from the quadratic terms plus 6x from the linear terms, and then we bring down plus 2 from the original constant term. Now the multiplier we need in the next step is to turn x square into 2x square, and that is the multiplier 2. And with this multiplier we generate the terms 2x square plus 6x plus 2. And now when we subtract, we will find that the remainder is 0. So in this part also the remainder is 0, which means that the first polynomial perfectly divides the second polynomial, or the first polynomial is a factor of the second polynomial. So that completes part 2. Now let's do part 3. In part 3, the divisor polynomial is x cube minus 3x plus 1. So let's write that first, x cube minus 3x plus 1. And then we will write the dividend polynomial. So the dividend polynomial is x to the 5 minus 4x cube. So there is no fourth degree term, plus x square plus 3x plus 1. So this is our dividend. Now let's start the long division process. So first we need a multiplier to turn x cube into x to the 5. So that multiplier is x square. And with this multiplier we generate the terms x to the 5 minus 3x cube. So minus 3x cube and plus x square. And now we subtract. So from the cube terms we get minus x cube. The x square terms cancel out, and then we're left with plus 3x plus 1. Now the next multiplier we need is to turn x cube into minus x cube, and that multiplier is minus 1. And with this multiplier we get the terms minus x cube plus 3x minus 1. And now when we subtract, the cubic terms cancel out, the linear terms cancel out, but we have 1 minus minus 1, which is minus 2, which is plus 2. So the division process terminates at this stage, because now the remaining part is only a constant term, and this is our remainder. So the remainder is plus 2, which is not equal to 0, which means that the divisor does not perfectly divide the dividend. In other words, the divisor is not a factor of the dividend. The first polynomial is not a factor of the second polynomial. So that completes part 3, and that completes this question.
Hi students, being good at math is super important because it helps you do well at school, but more importantly, it opens the doors for you to the most awesome careers of the future. Having taught thousands of students, I can confidently say that every student can really excel at math, including you. So I've created something special to help you become a master of math. Go to qmat.com/leap to find out more. I'll see you there.